Hello everyone, welcome to Advice International. So I have come up with the second part on arithmetic progression and geometric progression for the O-level candidates. So before starting, I would like to request everyone to subscribe my channel, like and share this video. So let's start. Okay, as you can see here, this question is from October-November 20, variant 1-2. The 7th and 10th terms of an arithmetic progression are 158 and 149 respectively. Find the common difference and the first term of the progression. So it's very easy. We use the formula of the term on arithmetic progression, which is this one, a plus n minus 1 into d. So they have given you the information of the 7th term and the 10th term. So using these two informations, you form two equations. Like T7, I got this equation, a plus 6d is the 7th term, which is equals to 158 as given in the question. Then T10, which is the 10th term, is 149. So using these two equations, I subjected a from both of these equations, and then I simultaneously solved them and I found the common difference and a. And finally, in the second part of the question, it says find the least number of terms, means you have to find the value of n of the progression for their sum to be negative. So negative means less than 0, and the sum should be negative, means the sum should be less than 0. So you simply use the formula for sum, n by 2 to a plus n minus 1 into d. So a and d we have already found out. So you can just place the values here, and then when you subject the value of n, this is how you solve it. You solve this inequality. You get n greater than 118.3, which is nearly 119. So this is the least number of terms. Let's move on to the second one. A geometric progression has a first term of 3 and a second term of 2.4. For this progression, find the sum of the first 8 terms. We have to find out the sum of the first 8 terms. So here we don't have the common ratio. They just gave you the first term and the second term. So you can just use the formula, which is ar to the power n minus 1. So the first term is 3 and the second term is ar to the power 2 minus 1, which is ar equals to 2.4. So this is how you subject r from here. So you get 0.8. So since r is less than 1, we use this formula for sum, which is a1 minus r to the power n divided by 1 minus r, and then you simply place the values. N will be 8 because they told you to find the sum of 8 terms, so the answer is 12.5. Then comes to find out the sum of infinity. The formula is this, a by 1 minus r. You have all the information, just place it down and you get 15. Then finally, here it says the least number of terms for which the sum is greater than 95% of the sum to infinity. So this is the key sentence. The sum is greater than 95% of means times the sum of infinity. So you simply place the formulas here, and you keep you have to subject n because they have asked for the least number of terms. So after subjecting n, this will look something like this. As you can see here, I have solved the inequality, and finally I get my answer as n greater than 13.4, which is nearly 14. You guys can stop the video and look at the steps, or you can take a screenshot. So let's move on to the next sum. The sum of the first 4 terms of an arithmetic progression is 38 and the sum of the next 4 terms is 86. Find the first term and the common difference. So this is quite a tricky question because there are total 8 terms. For the first 4 terms, the sum is 38, and for the next 4 terms, the sum is 86. But we don't actually know the numbers here. So what do? We use the formula for sum. First, we use the sum of the first four terms, which is n by 2a plus n minus 1 into d, where n will be 4, and then using the total, like in total there are 8 numbers, so what's the sum of total 8 numbers? So it's 38 plus 86, which is 124. This is the sum of total 8 numbers, like all of these numbers together. And your question might be like, why can't I take like the first four terms and then again the second four terms as 86? No, because sum is something you start adding up from the very first. So all of a sudden we can't just write S4 again will be equals to 86. We cannot do that because we don't know the numbers here, because sum means we are adding from the very first. So we have to add both of them together and get the sum of total 8 numbers. So this is how we solve it. This is S4 equals to 38 and S8 equals to 124. So we got two equations, then you simultaneously solve them, or you can do your like elimination method. I use the elimination method here, and I got A5 and A5, yes, and D3. So this was the sum. Let's move on to the next one. This is like part B. The third term of a geometric progression is 12 and the sixth term is 96. Find the sum of the first 10 terms of this progression. So again, we don't have our first term and the r here, which is the common ratio. So using these two information, where the third term is 12 and the sixth term is minus 96, you subject a, equal them, and you find the value of r. So now you have your a and your r as well. So now you can easily use the formula, and since my r is minus 2 and it's less than 1, we use this sum formula, which is a 1 minus r to the power n. I'm really sorry for the background noise. Okay, so here it goes. So this is the sum here. So this is S10. So I have the value of a and the value of r. So you just place the formula and you get minus 1023 as your answer. Let's move on to the next one. A geometric progression is such that its sum to 4 terms is 17 times its sum to 2 terms. So this is your key sentence. The sum of 4 terms is means equals to, is always stands for equals to, 17 times S2 means the second term. So again, S4, we use the formula, we use this formula, and since this is not equal to 1, that means it is not obviously 1. It has to be greater than 1, since it cannot be 1. So it has to be greater than 1. So we use this formula on both sides, and then you solve it, and you get r as 4 as plus minus 4. So r cannot be negative because it says here r should be greater than 1. So we accept 4 and reject minus 4. Now, given that the sixth term of the geometric progression is 64, find the first term. So we have our r, and we using the sixth term formula, which is a r to the power 5, we can simply replace r with 4 and find a here. And lastly, the last question, common question, explain why this geometric progression does not have a sum to infinity. We know the answer already, because the value of r is not between minus 1 to 1. Next comes October-November 21, variant 22, question number 10. The first 3 terms of an arithmetic progression are x, 5x minus 4, and 8x plus 2. So the first 3 terms are given to us. So I have done this. T1 means a, which is x. Then T2 is the second term. I just used this formula, a plus n minus 1 into d. I have a, which is x, and my d is obviously the second term minus the first term. This should be my d. So since I have my terms, I simultaneously solved them, As you can see here, T3, I used it. Then I could easily find X and D. So these are my answers. And then in number B1, it says find the value of Y. The first three terms of a geometric progression are given. So in order to find the value of Y, you can use the common ratio. Common ratio means second term divided by first term will be equal to the third term divided by the second term, because their common ratios are same. So this is how you solve it. You get a quadratic equation and you get the value of y as 2 and 8 by 17. Then for each values of y, the values that you have found here, find the corresponding value of the common ratio. So you just place them. R means T2 by T1. So this is one ratio I took. So one time you put the value of y as 2 and another time you put the value of y as 8 over 17. So you get two values of R. Now let's move on to the next one, which is October, November 21, variant 23. The arithmetic progression has first term A and the common difference D, the third term as 13 and the 10th term as 41. So using all the informations, T3 is equals to 13. This is the formula for the term. T10 is equals to 41. We simultaneously solve them and we find D and A. Then find the number of terms required to give a sum of 255. So you just simply place the value of sum here, where n will be your subject, and this is what we get. N is equal to 35. So n can't be negative. We reject the negative answer. Then comes, given that Sn is the sum of sum to n terms, show that S2k minus Sk means the sum of 2k terms minus the sum of k terms. So you have all the information, A5, D4, and this is the formula for a sum. So we just place the value of n as 2k here and place the value of k of n as k here. Then we get two expressions, this one, and then we subtract them, and then you can easily show this. Now let's move on to the next one. The first three terms of an arithmetic progression are log x to the power 5, and log x to the power 9. Show that the sum of n terms of this arithmetic progression can be written as this. You have to show this. So this is my first term. A is log x, then difference is second term minus the first term. This is what I have done, log x to the power 5 minus log x, and then Tn formula we know, a plus n minus 1 into d. So they have told us to find the expression for the sum. So this is the formula for the sum, and now we place all the values here, as you can see. Now here, as you can see, since it's in log, we know that if log is in subtraction form, we can divide it. So log x to the power 5 by x, you can write as x to the power 4. So this 4 comes front, you can write it as 4 log x. Then 2 log x plus 4 log x gives me, you multiply this 4 log x with n and minus 1, you get this. Then you can subtract 2 log x minus 4 log x, you get minus 2 log x, and 4n log x remains the same. Then you can take common like this. You can take 2 log x as common. So you are left with 2n minus 1, and you easily get this form where p is equal to 2. Now finally, hence find the value of n for which the sum of n terms is equal to 4950 log x. So they have already given you the value of sum. So this is the value, and you just place the formulas, and since you already got your all the values here, so log x gets cancelled out. So you're left with this equation, and n is 50, and we cancel out the negative 1. Finally, we have given that the sum of n terms is equal to this. Find the exact value of x. So we know that the sum is given. We have found out in terms of x, which is this one, the sum. So that will be equal to minus 14850, and then you simply subtract x and you get this answer, 1 by 1000. Now for the last sum, A geometric progression is such that 15 terms is equal to 1 by 8 of the 12th term, and the sum of infinity is 5. So there are a lot of information given here. So the 15th term is equals to 1 by 8 times the 12th term. So I have just used the formula and subjected r, and then they also gave you the sum of infinity value, which is 5. So since you got r here, you place the value of r and you get a easily. Finally, you have find the least number of terms needed for the sum of the geometric progression to be greater than 4.99. So I have my r, I have my a, and since r is less than 1, we go for this formula of sum, which is a 1 minus r to the power n divided by 1 minus r, and according to the question, the sum is greater than this. So you just place the values and you subject n. This is how you subject it. And finally, you get n greater than 12.3, which is 13. So this was the end of this chapter, which is arithmetic progression and geometric progression. So if you guys have not seen my first part, the link is given down in the description box. Please do check it out, and do wait for my next video that will be on tan curves. Thank you.